Hello, this is Mrs. Sargent, and this is lesson 3.3, orbital diagrams. So orbital diagrams follow along with the electron configurations that we talked about in our last lesson. And from the electron configurations handout, you already have some experience with orbital diagrams. We're going to review some of the rules and principles that you answered questions about, and then go through the process of how to draw orbital diagrams. So in orbital diagrams, the boxes represent the atomic orbitals in a sublevel, and the arrows represent the electrons. Each orbital can hold 2 electrons. So in the S sublevel, we said that there is one orbital, and there can be a total of 2 electrons. So we draw 2 arrows. I draw my arrows as half arrows because that's how I was taught to draw them, but sometimes when you see them printed, you'll see full arrows. The full arrows, like this, is fine, or you can draw a half arrow. I find drawing half arrows is quicker, so that's why I tend to still do that. For the P sublevel, we said that there is 3 orbitals, so we're going to draw 3 boxes that are connected. And then each orbital can have 2 electrons for a total of 6. The D sublevel has 5 orbitals, so we're drawing 5 boxes that are connected. And then each can hold 2 electrons for a total of 10. And then the F sublevel, a total of 7 orbitals. Each can have 2 electrons for a total of 14 electrons in the F sublevel. So there's different rules and principles in how we can fill up our orbitals. The Aufbau principle says that electrons enter the lowest energy first. So this diagram shows the different orbitals with their corresponding sublevels, and shows the increasing energy. So, which has more energy, 3D or 4S? Well, 4S is lower, so 3D is going to have more energy because it's higher on the diagram. And then which would fill with electrons first, the 4F, 5D, or 6S? Well, since we fill the lowest energy level first, 6S would fill with electrons first because it is lowest. So take a look at these orbital diagrams. Which correctly follows the Aufbau principle? You should have chosen the top one, because we can't skip over this box and fill in the 2p. We have to fill in that 2s first. The Pauli exclusion principle says that the atomic orbital can hold at most 2 electrons. And when there's 2 electrons, they're considered to be paired. and they must have opposite spins, which means that the arrows are going to go in opposite directions. So take a look at the orbital diagrams at the bottom of the page. Which orbital diagram correctly follows the Pauli exclusion principle? The bottom one should have been what you chose. We cannot have 3 electrons in one orbital, so the top one is incorrect. Hund's rule says that when electrons occupy orbitals of equal energy, one electron enters each orbital until all of the orbitals contain one electron with parallel spin, so the arrows are going in the same direction, and then they're going to pair. I like to think about Hund's rule that, like, if you go to an event and there is pizza, common courtesy would be that everyone would get one piece of pizza until everyone has had a slice, and then you can go through the line for seconds. So with our orbital diagrams, each orbital is going to get one helping of electrons within that sublevel, and then if there's leftovers, they can go back and get a second helping. So the bottom orbital diagram shows Hund's rule correctly. The top one, first orbital, and the 2p took a second helping of electrons. It's kind of rude. So that does not follow Hund's rule. So drawing orbital diagrams. Sorry. Get the spinning wheel. So we're going to follow the same thing that we did for the electron configurations. We always start at the 1s. We have to go through hydrogen and helium. So we're going to have 2 arrows. We'll go down to the next row, which would be 2s. We've got to go through lithium and beryllium, so 2 arrows there. And then to the 2p, there's 3 orbitals, so we're going to draw 3 boxes that are connected. And to get to oxygen, we need 1, 2, 3, 4 electrons. So each one of my 2p orbitals is going to get 1 electron, and then the first one is going to get that second helping. So all of the orbitals contain electrons, so we have a total of 5 electron-containing orbitals, and we have 2 unpaired electrons. To get to carbon, we're going to start off at 1s. We've got to go through hydrogen and helium, so 2 electrons there. Then we go to the second energy level, S sublevel, lithium and beryllium. And then to get to carbon, we need 2 electrons in the 2p. So the first box gets 1 and the second box gets 1. And that's all of the electrons that we have. For electron-containing orbitals, we only have 4 electron-containing orbitals, and we have 2 unpaired electrons. To get to magnesium, again, we're going to start off at the 1s. 2 electrons there. 2s. 2 electrons there. We're going to have to go all the way through the 2p, the sublevel. So we have 2 electrons in each of those orbitals. Since I knew I was going to fill it, I just went ahead and gave them the second helping to start with. And then in the 3s orbital, 1, 2 electrons to get to magnesium. So now we have a total of 6 electron-containing orbitals, and we have 0 unpaired electrons. So now we're going to draw an orbital diagram for nickel. Nickel is right here. So we're going to start off with 1s. Got to go through the whole 1s. And then we're going to go through 2s. P. We've got to go through that whole sublevel. So we're going to fill that up. 3s. Go through all of that, as well as the 3p. So we're going to fill up that whole 3p sublevel. The 4s sublevel, we're going to have to go through all of that, so fill up that orbital. And then we get to 3d, so now we need 5 boxes. Try to make these. And to get to nickel, we need 8 electrons. So I'm going to go through and give each orbital 1 helping of electrons. Go back 3 more to get my 8. So what sublevel has the highest energy? That would be 3d, because it's the last thing on my orbital diagram. In the 3p sublevel, we have 6 electrons. And then how many electrons are in the entire third energy level? Well, we have 6 in the third 3p, 2 in the 3s, so that would be 8. And then we have 8 in the 3d, so we have a total of 16. So you got to add the 3s plus the 3p plus the 3d to get your total number of electrons in the third energy level. And unpaired electrons, we have 2 of those. So that's it for today's notes. Thanks for stopping by, checking this out. If you have any questions, come in and see me. Thanks. Have a great day.